Yesterday, we have discussed regarding blocking and non-blocking statement. So, in this blocking statement, what happens is whenever we are going to write the statement inside the always or initial block until the execution of the current statement, next statement execution will be blocked. So as a result, here it has to wait until the execution of previous statement. But in case of non-blocking statement, they will not going to wait until the execution of the current statement. So whenever we are having a non-blocking statement, immediately they will going to execute as soon as the as it enters the block. That is nothing but always block or initial block. So that is why we are going to use non-blocking assignment, and this is one of the example. Here what we considered is the first four or the first six statements are blocking statements because we are using the symbol as equals. And these three statements, that is register A of 2, register B of 15, 13 and count. These three are non-blocking statement. So here what happens is execution of y equals 1 will happen only after execution of x equals 0. So like this they will going to execute. Since no delay is specified, all the statements will going to execute without delay. And the next one what we are having is the non-blocking statement. So here this will start execution, but after the time unit of 15, then it will assign value for register A. Means while executing this statement, it will not block the execution of next statement. The next statements will also execute immediately. So it will, this concatenation will happen, and after the 10 time units of delay, it will be assigned to left hand side. Similarly, the counter will going to increment, and as there is no delay, after incrementing, it will assign to the left hand side variable. So execution of this last statement is not blocked by execution of these two statements. Okay, because these two statements are non-blocking statement and these statements are blocking statement. Since these statements are also not having any delay, here the counter after immediately executing this statement, this will also increment and execute. So this is how we are going to consider non-blocking assignment. And in this non-blocking assignment, typically what happens is the non-blocking assignments will not going to block any previous or next statement execution, and they will start execution and it will complete only after the corresponding timestamp. So when the corresponding delay has been completed, then the value will be assigned to the left hand side. But usually it is not recommended to use both blocking and non-blocking statements in the same always block or initial block, because let me consider this example here. So here what we are having is always at positive edge of clock, we are having register 1 is equal to hash 1 in 1. That is nothing but input 1 will be assigned to register 1 after a delay of 1 time unit. And similarly here register 2 will be assigned with XOR operation of input 2 and 3 during the negative edge of the clock. And register 3 will be assigned with the value of register 1 during the after time delay of 1 time units. So here we are going to consider these non-blocking statements, that is reg1, reg2 and reg3. So how they will execute means, as soon as the positive clock occurs, positive edge of the clock occurs, immediately the value of in1, in2, in3 and reg1 will be read. Okay. And then whatever the value that was read, it will be assigned to the register 1 after a delay of time 1. And similarly, see, all the three are non-blocking statement. So none of these statements will going to block the execution of other statements. So while executing the statement reg3 equals ash1 reg1. So here what happens is, here we are going to consider the value of reg1 which was read during positive edge of the clock. So even though it has been updated with the value in1, that will not be considered. So during the positive edge of the clock, how many inputs we are having on the right hand side? One is in1, in2, in3 and reg1. All these values are already read, and those values will be computed and assigned after this delay. So as a result, here in one value, suppose let me consider input 1 is equal to 1 and input 2 is equal to 0 and input 3 is equal to 1 and register 1 before executing it is equal to x. Okay. So if these are the values read during positive edge of the clock. So here this is in 1 and this is in 2 and this is in 3 and this is nothing but register 1. So let me write it as R. So these are the corresponding values of the registers and input. So now while executing, means after complete execution, register 1 will be assigned with the value equal to 1 after a delay of 1 time unit, and then in1 XOR with in2, that is 0 XOR with 1 is 1. So register 2 will be assigned with a value during negative edge of the clock. Till the negative edge it will wait and then it will going to assign. And now register 3, which value it has to assign? Because register 1 is already updated with 1. But the thing is, during the positive edge of the clock, the value of register 1 was x. So x will be assigned to register 3. It will not going to assign the updated value. It will going to assign the corresponding value which it has read during positive positive edge of the clock. Okay. This is how it happens in non-blocking statement. And the same thing here we have considered. Here, see, it has been read the value and execution depends on the delay. If the delay is there, after the delay it will assign. If there is no delay, what happens? It will not going to consider in which order it is executed. Why it will not going to consider the order? Even though if it is inside the always statement, here they are all non-blocking statement. Since they are all non-blocking statement, execution order is not important. First only during this event occurring, the values will be read. So afterwards, while processing, those values will not be changed. Okay. After processing, during assignment, in any order, whether let it assign first value for register 1 and then value for register 3 or then assign value for register 2. It does not matter in which order it will going to assign. The thing that matters is what input it has read during this particular point. Okay. So that is why first it will going to read input at the very beginning before executing any statement, and only those input values are processed while executing each statement. So that is why it is mentioned that the order in which write operation are executed is not important, because the order that has, even though whatever may be the order, the input what it has been read, the same thing will be assigned. So that is why the order is not important. And let me consider one more example. So here, as I told, we are having two always statement, and these two always statement we are parallel execution. Means execution of first statement does not depend on execution of second statement. That is what we have considered. they will going to execute parallelly. Whenever the positive edge of the clock occurs, what this blocking statement will do? It will assign the value present in B to A. Similarly, during positive edge of the clock, the value of B should be updated with A. So now let me consider A is equal to value 0 and B is equal to value X. Okay, before the positive edge of the clock, let us consider A is equal to 0 and B is equal to X. So now what happens? During the positive edge of the clock, it depends whether the simulator will going to execute this statement first or this statement first. Because while executing, even though we can tell there is no dependency, the simulator will going to check whether, depending on the simulator, both the statement cannot be executed parallelly. Any one will going to execute at a time. So as a result, the simulator will going to decide whether this has to be executed first or this. So this is not under the control of designer. It is under the control of simulator. So if the simulator execute first always block, in that case, the value of A will be updated with the value X, isn't it? And then if the second always block is executed, now what happens? The value of B is equal to A means again B will be equal to X only. Means interchange of value will not happen in this particular case if you are using blocking statement. This is called as race around condition. That is, which one will going to execute first? That is the race. Depending on that, a common value will going to be there in both A as well as B. If you want to swap using the blocking statement, in that case, we cannot able to swap this. And similarly, instead of executing first statement, if the second statement is executed first, in that case, what happens? The value of B will be updated with 0, and after executing this, the first statement is executed. So as a result, A will also have a value 0. So like this it happens. Either both will have X or both will have 0, depending upon the race in which a statement always block has been executed first. This is considered as race condition. And this type of conditions can be avoided using non-blocking assignment. So when I'm going to consider non-blocking assignment, here we can see that always during positive edge, it will read the value. Assigning, it depends on the simulator time. But at the very beginning, for the non-blocking statement, immediately during positive half cycle, it will read the value. Positive edge, it will read the value. Here also during positive edge, it will read the value. Suppose, let me consider the same values. That is, if A is equal to 0 and B is equal to X. In that case, what happens is, during positive edge, the values will be read and stored in the internal memory of the simulator. Now, if the simulator executes first statement, first always statement, then the value of A will be updated with X. Now the simulator will execute second statement. So what this second statement will going to do? Before execution only it has read the value, right? So the previous value of A is 0. So B will be assigned with 0. So like this, it will going to exchange if we are going to use non-blocking statement. So that is why this non-blocking statement will eliminate race condition. Blocking statement will exhibit race condition, but non-blocking statement will eliminate the racing condition. This is how we are going to consider when we are using procedural assignments. And next, one more thing. If I want to exchange using blocking statement only, means I want to do the same operation using blocking statement, what we can do means we can take some temporary variable. Okay. So where using the temporary variable, I will save the initial value of A to temp A, and similarly, using the temporary variable, I will save the initial value of B to temp B. So now I will going to execute. A is equal to temp B. So initial value of A, let it be equal to 0, and initial value of B, let it be equal to 1. So in that case, what happens? That now the value of temp A is equal to 0 and the value of temp B is equal to 1. So I am writing A is equal to temp B. Since temp B is equal to 1, 1 will be assigned to A. And B is equal to temp A. Since temp A is equal to 0, 0 will be assigned to B. So like this it will exchange. But observe here, we are using 4 statement. Okay, in the previous case, here we have used only 2 statements. A equals B and B equals A using non-blocking assignment. Okay, so as a result, we can eliminate race around condition using non-blocking statement, even using blocking statement. By the use of temporary variables, we can able to reduce the racing condition or remove the racing condition. Okay, these are the difference between the corresponding non-blocking and blocking statement. And the next thing is here, when we are going to consider the non-blocking statement, we will get the output properly. But the thing is, it will increase the memory usage. So why it will increase the memory usage? So if the memory usage is more, then the performance of the simulator will be keep on reducing as the circuit complexity increases. If it is using more and more resource, means the performance of the device will going to reduce. So why it will reduce means, see, in this case, the first only it will read the value and store in temporary variable. While assigning, it will take data from the temporary variable and then it will assign. So here explicitly it is not shown or what is the temporary variable. Okay, so that is why here, if the number of statements increases, more temporary variable memory will going to be used. So as a result, the performance of the circuit will be degraded. Okay, if we use more and more non-blocking assignment statements, in that case, due to the large memory usage, performance of the simulator will be degraded. Okay, but wherever there is a racing condition, in such case, non-blocking assignment will going to eliminate the racing condition. And next, what we are having is time control. So when we are going to consider time control, so here it indicates that we are using a delay, because in the previous statements, first what we read is what are the corresponding blocks that is assignment statement that can be used in behavioral abstraction, that is initial and always. And when we know we have to use only initial and always statement to write the behavioral abstraction, then how to write expression? So while writing the expression, we can consider blocking statement or non-blocking statement. So we should know when to use blocking and when to use non-blocking. And the next thing is, if there is any delay, how we have to represent. So you know that why we have to consider delay, because this is a programming language to write program for the practical circuit. So when we consider a practical circuit, every circuit device will be having its own delay. So as a result, in order to process any particular operation, we can mention the corresponding delay in the using time control. So when we are going to consider time control, there are 3 types of time control. One is delay based time control, event based time control, level sensitivity time control. So when I am going to consider delay based time control, I will specify the delay, how much delay it has to take to execute. But when I am going to consider event based control, here I'm not specifying delay for every statement. What I will do means whenever a particular event occurs, then that statement has to execute, not always. Only when an event occurs, then it has to execute. That is known as event based time control. And the next last one what we are having is level sensitivity. So for this, during the introduction of this module, I gave an example of latch, either D latch or SR latch we can consider. So there, whenever the enable is high, in that case the value present in the input will be processed and will get the output. When the enable is low, in that case we won't get the output. So that is, it indicates the level, means the enable is high means it indicates logic high level. If I represent in terms of waveform, so I can consider this like this. So during logic high state, okay, in that case D latch will going to work, and during this particular time duration it will not work. Again during this duration it will work. So like this, it is sensitive for a particular level, either logic high or logic 0. That is known as level sensitivity. Okay, event based means, see, whenever there is a change in the information occurs. In this example, in the waveform only I can see. When there is a change from logic high to logic 0. So this is considered as one event. And similarly here also some event has occurred. So that is why it is changing value from logic 0 to logic 1. But here in this part, there is no event occurring. So that is why it will remain constant. So during the event occurring time, the delay is considered. Means some statements has to be executed. So such statements are considered as event based time control. In delay, we will specify exactly how much delay it has to take for every statement. So first, let us consider the first type, that is delay based time control. So in the delay based time control, what we are going to do means we will going to specify the delay using the symbol hash. In every statement, we are going to specify the delay, and that delay specification, for that we can have this as a syntax, that is after using the symbol hash, we will going to mention the corresponding delay value, and then I can use left hand side variable is equal to expression. Even when I consider this delay based time control, there are three types of delay. This delay based time control event level sensitivity. This is different classification. And inside the delay based time control, again there are three classification. That is regular delay, intra-assignment delay, and zero delay. Okay. So first, let me consider that. So here we are going to use hash symbol to represent the delay, and then the delay value can be represented by a number. Identifier means I can use like variables, and also I can use expressions. All these things I can able to use in this part. So let me have an example of regular delay control. So in this regular delay control, what we are having is we have defined two constants where parameter indicates the definition of constant. So latency means value 20, delta means value 2. So now I have defined the registers X, Y, Z, P and Q. So inside this always initial block, what I am mentioning is X equals 0. So I have not used any delay. So there is no delay control. And here what I have mentioned, hash 10, Y equals 1. So here I am using a number to specify the delay. And similarly here I am mentioning a constant. Latency is nothing but an identifier which I have defined for a constant value 20. So it will going to use this identifier. So up to latency means up to 20 time units it will going to wait, and then the value will be assigned. And here I have mentioned the expression because I am using the arithmetic operator, and this operator is having two operands, latency plus delta. So as a result, when it will going to execute at time 20 plus 2 means 22 time units of delay, this value will be assigned to P. And similarly, we are having ash y. So here y is a variable, it is an identifier, right? I have mentioned y is equal to 1. So after a delay of one time unit, it will going to execute x equals x plus 1. So this is how I can use delay. I mean, I can specify delay using either a number or a parameter, means a constant or an identifier or a corresponding expression. And also one more thing here, this type of delay we discussed using gate delays, isn't it? So there we had mentioned what is the corresponding minimum delay, typical delay and maximum delay. So here we are going to use this value as at least it should take 4 time units of delay to assign. Typically, if you know on which particular technology the IC is built, in that case we will be knowing on an average typically how much it will going to take a delay to assign a value. So that can be considered as typical value. Or at max, when we do not know on which particular technology or fabrication this circuit is built, in that case it can consider maximum 6 time units and minimum 4 time units of delay. This is how we can able to specify delay in regular delay control. And next one what we are having is intra assignment delay control. So intra assignment means here before assigning we are going to apply the delay. Here you can notice the change. In the last class I mentioned the delay, that is syntax. So while writing the syntax, what I have mentioned, so I have mentioned that we can write delay before this assignment statement, or else we can write delay after the assignment statement. So here what it happens is, first only in this initial block it will read the value of x as well as z, and then it will compute the value of x and z. Okay, so now let me consider the values of x and z are 0, and then after 5 time units 0 plus 0 means y will be assigned with 0. Meantime means before 5 time units of delay, if the value of x or the value of z changes, it will not going to bother. Whatever the previous value that has been used while calculating this expression, the same will be retained. This indicates that it will not going to execute after 5 time units of delay. It will execute first, but it will assign after the delay. That is the difference. So when we have considered previous statements, so there what we have used is, in case of gate delays as well as in case of data flow modeling, there also we have used delays. So there what it used to do, it will wait for that particular time, and while during that particular time, what is the value is there, that will be calculated and then it used to assign. But here what happens, first only it will calculate and keep the value in temporary variable, and after the delay period completes, then it will assign value to the LHS side. That is the difference between intra segment delay and other types of delay. So in case of intra segment, first only expression will be evaluated, but the value assignment will be done after this delay. And in previous cases, what happens, after the delay, value has been read and expression was evaluated and assigned in case of data flow as well as gate delays. But in case of intra segment delay, you have to clearly remember this delay. That is the main difference why we are going to use intra-segment delay compared to other delays in data flow assignment. Okay. See, for example, these statements can be written in data flow assignment also, isn't it? So if I do not use the initial statement, directly I can write this expression, means I can declare wire x comma y comma z in data flow modeling, and then I can write x is equal assign x is equal to 0 and assign z is equal to 0, and then I can write assign hash 5 y is equal to x plus z. Okay. So now, what is the difference between this statement and what is the difference between these statements? I have used the same expressions. Okay. But these are present outside the always or initial block, and the same statements are present inside the always or initial block. So what it will do, whenever the value of x or z changes, it will wait for 5 time units of delay, and then after 5 time units, what is the current value present in x and z are read, and this expression is evaluated. Okay. So within this 5 time units of delay, if x has been changed from 0 to 1, so after a fight, let me write a waveform here. So at 0 time, and then let this is equal to at time 5 time units, and this at time 10 units. So now here we are having x, and then we are having z, and then we are having y. Okay. So at 0 time unit, x is equal to 0 and even z is also equal to 0. And when the value of y will be assigned, it has to wait for 5 time units. Till then, it will be having unknown as the input. Unknown as the result. And now, before assigning, after this 5 time units of delay, what will do means, it will read the value of x and y. So now let me consider the value of x has been changed from 0 to 1 and z has been retained as it is. So during this 5 time unit, the value of x is 1 and z is 0. So y will be assigned with 1. Means the change in the data has occurred at this time. Means it has been changed at 0th time. But before getting 5 time units of delay, x has been changed. That change is considered while calculating the value for y in case of data flow architecture. Okay. But when I'm going to consider behavioral architecture, the same statements I have placed here, but what happens is, it will not going to take the changed value of x. Even though if the x changes before 5 time units, it will not going to take that change. It will going to take the previous value that was presented, and then it will execute. But after this delay, it will assign. Okay, that is how we are going to consider intra-assignment delay. And this is one of the example we are considering. So here also we are here what we are doing is, we are considering x equals 0, z equals 0, and here I am using the expression that is temp of temp xz is equal to x plus z, and then I am using after this delay I am writing y is equal to temp xz. So here what happens is, first it will execute these two statements, then whatever the value is there, it will be computed, and without delay it will be assigned to temp xy, and then here I have mentioned the delay. So what it will do, it will wait for 5 time units of delay, and then it will execute this. Okay. But in the previous case, what it will do? It will execute this first and wait for 5 time units of delay and then assign. Okay. This is what we are going to consider. So even though if I want to mention the intra assignment using this type of regular assignments, I can do like this. Okay. So within this 0 to 5 time units, even though if the value of x and y changes, that will not be affected, because this whatever the value present in temp xz, the same will be assigned to y. Okay. This is how we are going to consider intra assignment delay. So the difference I have mentioned clearly. The difference between intra-assignment delay and regular delay is regular delay defer the execution of the entire assignment. Means it will wait for a delay and then it will execute. But intra-assignment delay compute the RHS expression at the current time and then defer the assignment of the computed value to the LHS. Means after the delay, it will assign the value. So like this, we can able to use intra-assignment delay as well as regular delay. And even intra-assignment delays are like using regular delay with a temporary variable. See, why we are going to consider it as temporary variable means here also it will not going to change the value, because whatever the initial value is there, that is computed and stored in the temporary variable, and after the delay it is assigning. Here also we will get the same result. So that is why this intra-assignment delay acts like storing the expression result in a temporary variable and afterwards it will do the assignment. That is what this statement tells. Okay. And next, what we are having is zero delay control. So when we are going to consider this zero delay control, so usually in the while writing the statements in this example only, I'll directly take the example and explain. So here I have mentioned it as ash 0. In this case, we can see these two initial blocks. So in the first initial block, I have not mentioned any delay, x equals 0 and y is equal to 0. But here I am specifying ash 0, x equals 1 and ash 0, y equals 1. What happens is, while executing, okay, the assignment, first the right hand side will be executed and then that value will be assigned to left hand side, isn't it? So while doing assignment, again all the statements will not be assigned at a common time. There will depending upon the simulator, some statement will be assigned first and then some statements will be assigned later. But when I mention ash 0, what it will do? It will assign this value after 0 delay. Means before instantly it will not going to assign. First it will going to do these assignments. By the end of the time 0, it will assign. Okay, that is what it means. So if I consider 0 simulation time, so in that how I can give comparison? For example, if you are going to change the value, if you are going to consider the value 0 as well as 1, okay, if there is a change in a value from 0 to 1, it will take a fractional amount of delay to change a value from 0 to 1, isn't it? So in that fractional amount, at the end, it will going to assign, not at the beginning. Okay. So when I mention ash 0, it will going to execute at the last, not at the first. If I do not mention anything, then there will be a race. So either this will be executed first, means this will be assigned first, or this will be assigned next. But here, if I mention it as ash 0, then After doing all the assignments, at the last this assignment will be done in before completing the initial block. This is what it means about zero delay. Usually we are not going to use zero delay. As soon as the values are completed, before coming out of this end statement, the values should be assigned. So while assigning, at the end we have, if I mention two zero delays, then how it will going to consider two assignments at the end? So it has to follow the corresponding simulation assignment protocol, because sequentially it will going to assign, but it doesn't mean that which one will be assigned first and which one will be assigned next, but at a time only one statement assignment will be done. So that is why usually we are not going to use zero delay, but this option is available in Verilog HDL. Okay, this is regarding regular delay or delay based time control. So in delay based time control, we are having three types of delay: regular, intra-assignment and zero delay. In regular delay, it will wait for that time and then it will execute. But in intra-assignment delay, it will execute and then it will assign. Okay, so in order to intra-assignment delay acts as a temporary memory to store the corresponding executed value of the expression and then assigning. Okay, that is the difference between the regular and intra-assignment.